Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.1, Problem 17. This is Section 15.1, it's problem number 17. We want to find the integral of 3x squared minus 2x plus 7 all over x squared. Now what makes this one a little different than some of the other problems in this section is the denominator. And the denominator has a variable, so we have to do something to write this problem so that there's no variable in the denominator before I can do the integral. So the way to do that, I call this the common denominator trick. Instead of having one big fraction with one denominator, I'm going to split it into several little fractions and reduce each one. So the 3x squared that I started with on the top becomes 3x squared over x squared. The minus 2x from the middle becomes minus 2x over x squared. The plus 7 on the end becomes plus 7 over x squared. I keep my integral symbol, my dx on the end, and now those three separate smaller pieces I can reduce each one. So again, I haven't done the integral yet. I still have my integral symbol. The first one, 3x squared over x squared, reduces very nicely. The x squares just cancel. I have 3. The next one, I have 2x over x squared. So that's going to be 2 over x, which I will write as 2x to the minus 1. So again, the x on the top will cancel and make it an x to the first in the denominator. But I don't want variables in the denominator. That's why I choose to write it as 2x to the negative 1. And on the end, the 7 over x squared. Again, to write that without having the variable in the denominator, I'll write it as 7x to the negative 2. And again, when I do an integral, I need to have the dx on the end. Now I've written the same problem, but without the variable in the denominator. So now I'll just take the integral of each piece. This 3, it's just written as a 3. It comes from a 3x. You can assume that it's a 3x to the 0. I wrote 3, but it's the same as 3x to the 0. So now the 3, that's the number in front, will be in the numerator of a fraction. In the denominator, you have the old exponent of 0 plus 1, x to the old exponent of 0 plus 1. Now the next piece, minus 2x to the minus 1. This has come up a few times before. If we apply that same formula, which seems like we should be able to, we're going to have a problem. So let's see what will happen. So minus, the number in front is 2, and that goes in the numerator of a fraction. Then in the denominator, you have the old exponent of minus 1 plus 1, and then x to the old exponent of minus 1 plus 1 more. Now when I go to simplify that, that minus 1 plus 1 gives me a 0 in the denominator, which is undefined. That will not work. So let's drop down one more line. I can clean this one up a little bit. 3 over 0 plus 1. Let's just make that a 3x. And the x to the 0 plus 1, just x to the first or x. Now, let's deal with this minus 2x to the minus 1. Clearly, the routine that I use for all the other parts of this integral and most integrals don't work. I get a 0 in the denominator, which I cannot have. So that sends up a little bit of a flag that you have to try something else. And what you try is you make the natural log the answer, natural log of absolute value of x. And the minus 2 in front just stays in front. That's how you deal with an exponent of negative 1. Now the last piece is 7x to the minus 2. This minus 2 is fine. That's not going to give me any trouble. So I have plus, the 7 that's in front is in the numerator of a fraction. Then in the denominator you have the old exponent of minus 2 plus 1 more. X to the old exponent of minus 2 plus 1 more. That'll be fine. That doesn't zero out the denominator. Don't forget I have a plus c on the end. And I can clean up the fraction here a little bit. So this answer starts with a 3x, I can leave it. The middle piece is minus 2 times the natural log of the absolute value of x. I'll just leave that. That's not going to simplify. The piece on the end, though, 7 over negative 2 plus 1, x to the negative 2 plus 1. Well, I have 7 over minus 1. Let's just call that minus 7. 7 over minus 1 is minus 7. X to the minus 2 plus 1, again, that'll be minus 1, plus some constant. And now that's the answer. This one's a little bit more difficult to take the derivative and send it all the way back here. It requires more algebra than it does calculus. So I'll just say that that is the answer.